Welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but want to be its friend. I am your host, Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a friend to the universe. And today I'm joined by a new friend, Orli Matlow, who is a comedian and writer who I met on the WGA picket line, which I think is a really cool way to meet someone. And I've thoroughly enjoyed her Instagram presence ever since. So Orli, thanks for being with me today.
Thank you so much for making this introduction to the universe. I feel like, long time listener, first time caller. I'm ready to learn about what's out there.
I am so excited to be with someone else who wants to learn. Speaking of learning, what do you think the listeners should learn about you before we get into the episode?
Yes, I am. So stand-up comedian, writer, and also a trivia host. So I host trivia all over New York City. So I'm grateful for any opportunity to learn and then pretend not to be surprised when I reveal the answers at various bars throughout the city. So I feel like, the more you know is helpful, and also grateful for more things to make fun of.
Always.
We'll see what's out there, and everything can be hilarious.
Yes. With
the right attitude or the wrong attitude.
Do you get to make the trivia questions?
No, it's NYC Trivia League. Yeah, it's just plug and play. So I feel like I'm learning along with the players.
Okay. Well, hopefully one day soon you'll get a question about today's topic, and then you'll really know it, and that'll be exciting. But before we get to that topic, can you tell the listeners where you've invited me to record with you?
Yes, we are here in the Berkshires today. So I feel like I'm just reconnecting to the universe. This past weekend, I went to a friend's wedding, Mazel Tov, Kira and Alex, and it was so much fun. And it was up in Western Mass, and it was my first time leaving the city in a while. And it was wild. I was like, oh, I remember the moon. It truly...
Well, you can still see the moon from New York, Orli.
I know, but it was so much clearer, so much less fuzzy. I can't remember the last time I saw stars. So it was exciting to be out in the world with minimal smog, or as much as I love the Empire State Building and various skyscrapers, they totally dominate the nightscape. So it was cool to be out in the woods and to see some stars, and then now to hopefully learn what they mean.
Yay! We are going to be learning about some stars today. A little bit of a spoiler. Today we're talking about variable stars and the woman who solved their mystery, Henrietta Swan Leavitt. But first, in order to fully accept you here at Pale Blue Podiversity, and to understand what classes to put you in the future, we do have a little preliminary exam. This is a new department, so we're still working out some bugs with the exam questions, but I think we've landed on 9 questions to figure out who you are, Orli, and where you fit within our podiversity here. Is that okay with you?
Excellent. Yeah, I'm excited to be pledging the system.
Pledging the system. I love it. Okay, we have 9 questions for you, and there are basically no wrong answers here.
Oh, thank God.
Question 1. What is your current relationship status with the universe?
Full intimidation and fear.
Oh.
Yeah, I live in New York City because I feel comfortable around anxiety, and this is like the default mode in this entire metropolitan area. So I feel absolutely intimidated.
Wait, okay. So it sounds like the universe causes you stress, but you also love being in that stressful moment,
exactly.
Right? Because that's why you live in New York?
Yeah, I feel like connected. I revel in stress because I feel like, okay, this connects me to the world and others. But yeah, it's very intimidating. I don't even astrology, let alone astronomy.
Well, you're in the right place.
Yeah.
Okay, so it sounds like you are in a slightly toxic relationship with the universe, but you're happy about it.
Absolutely. Exactly.
Okay, good to know. Question number 2. Do you have a favorite equation?
Oh, fun. The first thing that comes to mind, I've seen on many a motivational poster, there's all the Albert Einstein, like, genius. And then that's E equals MC squared, eh? That's his catchphrase.
That is it. Although that is a simplified version of this. So you can take this with you. You can use this at dinner parties or something, Orli. Maybe work it into a stand-up routine. I would love to see how you do this. But there's an extra term in that equation.
Ooh.
They've lopped off the end of the equation. It's actually less elegant than people know. The real equation is E squared equals M squared C to the fourth plus P squared times C squared. So there's this extra term in it that has a P, or momentum, but we can usually lop off the end of that equation because momentum is usually 0.
Oh, that's funny. That's like back when Twitter had like a shorter character count, like brevity is the soul of wit. And even Einstein was like, that's redundant. We can lock that off. That's like comedy writing mentality.
Good. Yes. It was good marketing on his part. All right. Fantastic. Love that as a favorite equation. Question 3. You don't have to tell me what your sun sign is if you don't want to, but I do want to know, do you feel like your zodiac sun sign fits you?
No, so I'm going to be transparent. So I'm a Scorpio, and I talk about it on stage because all the time people are like, oh my God, you must be like so moody and mysterious and just horny all the time. And I'm like, I'm too medicated for that. Like, I feel like I joke on stage that SSRIs are more powerful than the stars, because I feel like my sun sign is just, nullified by Prozac.
Wow, they should put that on the box.
Yeah. I'm hoping to get a sponsorship. Let's get this podcast sponsored by like a pharmaceutical company. Like, brought to you by Pfizer.
Oh, I wish. I just got my boosters. Everyone, if you haven't yet, go get your COVID boosters and your flu shot.
Amazing. Same. Yes. And it pretty much, it knocked me out. Like, so get it, and then you fully have an excuse to cancel plans for at least 2 days. And like, that's to encourage you to get it, not to discourage you from getting it.
Right. Because even if it's fine, you still have the excuse.
Yeah. There's so much TV to catch up on. Like, sorry, now I'm just, speaking of intimidation, I'm like, it was just the Emmys, and I'm like, damn, I need to watch all of Shogun.
Yes. Oh, they really give me so much FOMO, because it makes me realize how much TV I'm just never going to be able to watch with my time.
Exactly. Yeah, it's much like the universe. It's infinite.
Yes. Oh, I can tell you're a good fit for the podiversity already.
Oh my gosh, thank you.
Mm-hmm, but we do still have to get through the whole exam. So question number 4, is Pluto a planet?
No. I remember its demotion. I remember like that was a major media story. Mm-hmm. And like I remember seeing like people telling jokes, like I guess like the only Pluto now is it Mickey and Minnie's dog, Pluto?
Yeah, I don't know if he's like their pet or a neighbor, but there is a...
But like Goofy
No, Goofy is the neighbor. Yes.
Yeah, Goofy's the anthropomorphic dog that talks, whereas Pluto doesn't talk. So it's like a tiered society of like what dogs get respect in Toontown. But as far as I remember, I don't know if there's an update, but last I heard, not a planet.
All right. I appreciate you going with the official scientific answer.
Oh my gosh. Thank you. This is my parents are definitely listening to this. They're going to be so proud. This is the first time I've been acknowledged for my scientific prowess. They're going to be so proud.
Yeah, you get a gold star.
Yay!
There was no real wrong answer there. I would have accepted anything as long as you backed it up. Yeah, it's all about how you feel in your soul.
Oh, okay, Pluto is a state of mind.
As are we all. Okay, speaking of state of mind and getting in the right state of mind, imagine you are an astronaut going on a mission. What song are you listening to during launch?
Oh, that's so fun. Probably the first thing that came to mind was immediately Don't Stop Me Now by Queen.
Yes! Oh, Orli, that's perfect.
Oh, thank you. Isn't there like a lyric? It's like, falling through the sky, yeah.
200 degrees something, yeah.
Exactly. Obviously, like when Space Oddity by Bowie comes to mind and Rocket Man by Elton John, but those are both like moody when you're like stranded, wandering through space, getting introspective. But like Don't Stop Me Now is a launch song.
Yes. Okay, I see your brain is also firing on all cylinders. I think that your admission to the university, to the Podiversity, is all but foregone. It's a foregone conclusion.
Thank you. I'm not even a legacy. This is huge.
You're getting in on your own merit completely. Next question. Would you rather be an M-type star burning low and slow, or an O-type star burning hot and fast?
Oh, wow. Yeah, I think there's something to be said for longevity. I wouldn't want to crash and burn.
Okay. All right. You don't actually have to know anything about what those types of stars are or what they mean, but yeah.
No, that was a good description. That was like the equivalent of like, would you rather be a one-hit wonder or have a sustained, albeit like not so famous career, but to be like a character actor consistently working over time, to be like Richard Kind is an M star, it sounds like.
Yes, perfect. Okay, so you're the Richard Kind and not the I'm only going with music, not the 303, not the one-hit wonder.
Yeah.
Okay, love it. Next question, so it's very open-ended. Name something scarier than a black hole.
Oh my gosh. Scarier than a black hole is a singles mixer. I actually went to one at a bookstore last night just because I was curious, at Book Club Bar in the East Village, Lower East Side. And like, they were very smart with their advertising, that they used like pictures of Julia Roberts and Hugh Grant and Notting Hill. And so like, who hasn't had that rom-com fantasy of having a meet cute in a bookstore? But I went yesterday and it was terrifying, because it's like, you don't want to cock block anyone. So like, it kind of felt like The Bachelor. You didn't want to be like, can I steal him for a sec? So instead, like,
you're too much of a girl's girl.
Oh, thank you. Yeah, I only interjected myself into group conversations because I didn't want to like ruin anyone's connection. So I just had some nice group conversations where we talked about like, yeah, I've been reading a lot of historical fiction lately. But yeah, there was no meet cute. But I hope the other women did, because of my self-sacrifice.
I hope they did too, so that it was worth it. And
yeah, I paid for a ticket, but I got a drink ticket.
Okay, there's that. You got an overpriced drink out of it. I hope that one day you get to go to a fun singles mixer near a black hole. And you can all bond over getting spaghettified by the black hole, because you're too close to it. Have you heard of spaghettification?
No, but that's an incredible verb.
Okay, great. We're definitely going to put you in the spaghettification class here at the Podiversity. But just as a primer, it is when you get so close to an object with really strong gravity that it rips you apart, except it really just like stretches you out into these long strands that look like spaghetti.
Oh, that's fun. That's it's only a matter of time before like Hollywood sells it to us as a weight loss technique.
Oh, you're so right. You're so right. Forget Ozempic.
Exactly. Get spaghettified at a black hole.
Okay, next question is 50-50. It's up to you. Moon or sun?
I feel like I gotta say sun, because fun fact, my name Orli, it actually means my light in Hebrew, which is very sweet and a lot of pressure. But like my whole life has just been a lot of like light metaphors from my parents. So I feel like, yeah, my name, it's got to be the light.
We got to go with the sun. I love that. My name, according to my parents, means my greatness. So I've also felt a lot of pressure.
Yeah, that's beautiful and intense. Yeah.
And intense. Yeah. I'm doing my best, Mom and Dad.
Exactly. That's all we can do.
Okay. Are you ready for your final question on this preliminary exam?
Let's do it.
There is no benchmark for success here, but how many constellations can you name?
Oh my gosh. Maybe only one or two, or I don't know if these are constellations, but we got the Milky Way and Orion's belt. Are those constellations?
Technically, no.
So zero.
So zero. That's fine. So the Milky Way is the galaxy. It's like all of the stars that we can see in the plane of the galaxy. And Orion's belt is 3 little stars. I can actually demonstrate because I have a tattoo of it.
Oh my God, that's so cool.
is 3 stars here in the whole constellation of Orion, which is all of these stars. So I'm going to give you Orion.
Cool. Okay. Yay, one.
I bet you could also name another one if you said your zodiac sign again.
Oh, yeah, Scorpio.
So Orion and Scorpio are 2 constellations very close to the ecliptic, very close to where the sun seems to pass in the sky. So
another good launch song. Total Eclipse of... Oh, no, that's Total Eclipse of the Heart.
I would be concerned. I think it would make me yearn for something. And I don't want to be yearning, while I'm launching in a rocket.
Good call.
All right, well, you have done incredibly well on your preliminary exam. We're going to get you into that spaghettification class, and, the deans of the podiversity are going to figure out what other classes we should place you into.
Amazing. Thank you. Yeah, I'm grateful. If there's no language requirement.
Just the language of love for the universe.
Excellent. And my extracurriculars, made sure to be focused on a lot of extracurriculars to be a good candidate.
Okay, fantastic. Yeah, and that's all elective. And we have some really fun ones here. You can go, we have a spacewalk where you can go to the ISS and do a spacewalk outside of it. We have so many fun classes here at the Podiversity. Options are endless. But you did say in your application that you were especially interested in learning about Henrietta Swan Leavitt. Can you tell me what drew you to her?
Absolutely. So fully, it was just, I saw the list of incredible courses you had to offer, and I was like, that's an incredible name. And I can imagine that her, as a person, she lives up to her name as an incredible person, as she does have an incredible name. And obviously we love women heroes and are grateful for any opportunity to learn about cool women.
Yes, same here. Do you know anything about Henrietta before we get started?
No, I'm here fully blind.
Perfect.
Didn't even Google.
Yes. Okay, pure intention. We have a blank slate, a tabula rasa here. I love it. Is there anything you would like to know by the end of the episode? Just a shot in the dark question about Henrietta Swan Leavitt?
Oh, does she have anything named after her that I can then go visit?
Oh, that's a great question. And I have that in my notes. I will be answering that by the end of the episode. Fantastic. Okay, well, let's start with her start. Let's start where she did. She was born on 4th of July. She's a little Independence Day baby.
Easy to remember.
Yeah. You don't have to write that down. It was after independence happened. It was in 1868, and she was born in Lancaster, Massachusetts. We say it that way in Pennsylvania. I don't know if it's Lancaster in Massachusetts, but that's where she was born. Her parents were George Leavitt, who was a minister and very, very involved in the local religious community, and her mother, Henrietta Swan Kendrick. So she's a junior. She's named after her mother.
That's sweet. That's also a lot of pressure. We were talking about the pressures from our name, but to literally be your mother's mini-me.
Mm-hmm. I do know that she was one of 7 children, but a couple of her siblings died as infants, I think. And so there were other siblings around to maybe take some pressure away, but she did have the whole namesake thing going. So that adds to it.
Yeah, and by living past toddlerhood, she already nailed it. So
she was already doing her parents proud.
Yeah.
Mm-hmm. Yeah, back in those days, for sure. I couldn't find much about her childhood and what she was into, but she was very involved with the church, and she suffered from poor health for most of her life, various chronic illnesses, although we don't know exactly what they were. It was the 1860s,
Yeah. There was chronic illness in the water.
Yes. But I did hear more about her education and her professional life on my searches. She started at Oberlin College, which I'm pretty sure is in Ohio, in 1886. Are you familiar with Oberlin?
Yeah, now it's known for being there's a conservatory, but also it's a super fun, hippie liberal school. So I didn't know they had science, or at least They did back then.
And they still do. I visited Oberlin. They have the music conservatory, which I was not going for, although I did play the clarinet as a wee lass. And I also know that they have an alpaca farm nearby.
Oh my God, that's adorable.
Yeah, I imagine it's good for the students if ever they're stressed.
I wonder if Henrietta ever went, or if they had it at the time.
Oh, I like to imagine so. Let's just add that to the headcanon.
Yes.
Yeah.
If not Wikipedia.
But she was only there for 2 years before she transferred to what was then called Harvard University's Society for the Collegiate Instruction of Women. Very fancy.
Wow.
It was later renamed to Radcliffe College, which is the sister college to Harvard. And we talked about this in our Annie Jump Canon episode a little while back. And if you listen to that episode, you will also notice a lot of similarities between Annie Jump Canon and Henrietta Swan Leavitt. They interacted a lot. Leavitt graduated with bachelor's in 1892 from what was eventually called Radcliffe, and she did get a pretty liberal arts education. She studied Latin, Greek, philosophy, various maths, including some calculus and geometries, and in her senior year, she took an astronomy course, which I think ignited this passion within her because she didn't let it go for the rest of her life.
I love that. That's a meet cute.
You're right. She had a meet cute with astronomy. If we shifted our understanding of meet cute to encompass more things like that, I think we'd be happier with our lives. I also had a meet cute with astronomy. I have meet cutes with books in bookstores.
Yes, exactly. What was your meet cute with astronomy? I'm sorry I'm sure you've told this story on the pod before, but I love a meet cute story.
Yes. So I was a sophomore in college. Astronomy was thousands of years old. And I walked into a classroom totally uninterested because my friend dragged me along with her. And I sat in the back of the room. I was going to be the cool kid. And in that first class, before we had to actually register for it, the professor said we would get free pizza every week. So I signed up.
Oh my gosh.
So it was, at first, a relationship of convenience.
That's so funny.
By the end of the semester, obviously, I was hooked, and the rest is history.
Oh my gosh, I love that. The power of pizza, for all the educators listening to this. Mm-hmm. Wow.
Yeah, pizza is so powerful. Get one gluten-free one for your class, and you're good.
But yeah, that shows adaptability.
Mm-hmm. Mm-hmm. Hi friends, Orli is out looking for sticks so we can roast our marshmallows later, so I figured that I would take this time to share a couple of messages with you. The first is that there is now Pale Blue Pod merch. I'm selling a t-shirt that says the moon is for the people and a crew neck sweatshirt that says eat the sun. I'm selling these both in time for chili season, although it is very warm in New York City right now, and in time for gift season. Everyone I know is getting a PBP sweatshirt for Christmas. You can get yours at the link in the show notes or at palebluepod.com at the little merch tab up at the top. Okay, my next message is a podcast recommendation. It's a podcast that I listen to every single week, and it's called Spirits. It's a history and comedy podcast focused on everything folklore, mythology, and the occult, told through the lens of feminism, queerness, and modern adulthood. I love every single thing about it. Every week, mythology buff Julia and her childhood best friend Amanda get together to learn about a different story from mythology and folklore over drinks. That's why it's called Spirits. It's a pun, get it? They cover everything from the mythological origins of major franchises like Lord of the Rings and Pokemon and Wonder Woman to modern urban legends to a roundup of werewolf stories around the world. Anything myth-focused that you can imagine, they have covered it on the show or they are planning to cover it in the future. You can start with any of their 400-plus episodes that they've released over the last 7 years because they are podcast goals. There's so much to enjoy at Spirits, whether you are there for analyses of mental health and mythology or creepy modern ghost stories. You can dive in at spiritspodcast.com or search for Spirits wherever you download your podcasts. Before I get back to the show, I want to thank my patrons who support the show every single month. Thank you all so much. But a big special thank you to my Sun Like Stars, Scott Reynolds, Augustin, and Tom T. Thank you. I love you all so much. Remember, you can become a patron and hear your name on the show, make your mark on our patron star chart, and get research notes or like a works cited for almost every single episode, all by supporting us on Patreon for about $1 per episode. You can sign up for an annual membership where you get a 13% discount across an entire year by signing up for a whole year up front. And that way you win because you get that discount, and I win because I know that I have a year's worth of support to count on. You can find our star chart, our Patreon info, and more at our website, palebluepod.com. Or if you already know you want to support us financially, you can go to patreon.com/palebluepod. Of course, if that's not a thing you can do right now, that's totally fine. You're still space, and I love you very much. There are other ways that you can support the show. You can rate and review us on whatever podcast app you use, and sometimes when I'm looking for a little mood boost, I go and I read them, so please leave a review if you like the show. You can also share the show with your friends by taking a link to a specific episode and sending it to someone who you think would enjoy it. That is the best, easiest, fastest way to help a podcast grow. All right, Orli is back. Those are some excellent roasting sticks. Let's get back to this chat. So she graduated in 1892 with her bachelor's degree, and then she started working towards a graduate degree also at Radcliffe, but she was getting sick a lot and she wasn't able to finish the degree ever. But that's okay, because she eventually still became a badass professional astronomer, even without any advanced, like, tertiary degree, I guess is what they're called. For a little bit, she takes a step away from her research and she goes on a trip to Europe to have a good time as a young lady in Europe. And she also takes a job as an art assistant in Wisconsin. And she does that for a year or two when she gets really sick with something that leaves her deaf. And she was mostly deaf for the rest of her life.
Oh, wow.
She went back to Harvard and asked someone at the observatory named Edward Pickering, who was in charge of this group of women running calculations in the observatory, went back to him and asked if she could have a job there, because she had done some work on his team right after she graduated. So she was like, can I have this position back? And because she, at least what I read on the internet, made it seem like he took pity on her because she was sick and because people kept saying that doing any sort of strenuous activity or activity outside would exacerbate her illness. He gave her a job working inside the observatory for 30 cents an hour, which was still nothing.
It's as bad as it sounds.
Yeah, it is. Like, if you account for inflation, I think it's still like $10.50.
That's still, she was being exploited, but they were took pity on her by exploiting her. Classic.
Well, she was even making 5 cents more an hour than the other women who worked under Pickering.
Oh, wow.
Yeah, so she was being slightly less exploited than everyone else, but she did have a job. She was employed to do science at the Harvard College Observatory, which is a huge research institution back then and still today. She was officially hired in 1903 by Pickering to measure and catalog the brightnesses of stars. And she was specifically looking at a particular type of star called a Cepheid variable in the large and small Magellanic Clouds. Do you have any questions after that?
Yeah, Magellanic, that's like Magellan the explorer. That's like what he used to sail.
Yes. So Ferdinand Magellan, he was the guy who was credited with doing a circumnavigation around the globe, but he didn't make it. He died before he made the full trip. He gave his name to these two small satellite galaxies that orbit around the Milky Way called the Large Magellanic Cloud and the Small Magellanic Cloud. He gave his name to them, but they are very important in a lot of Southern Hemisphere cultures' folklore. And so there's a movement now in astronomy to change their name to something that would be like something from an indigenous language, either Hawaiian or something. People who have more of a connection to them.
Oh, that's so interesting. Did he name them himself in his lifetime? He like Columbus those clouds?
That's a good question. I don't know if he did it or if someone else named it after him. I will check after the episode.
Because I could just imagine like having the confidence to be like, yeah, this sky belongs to me now. Those are mine.
They were doing things like that a lot back then.
Yeah.
Yeah. But the Magellanic Clouds are two small galaxies that are relatively close to the Milky Way. We're talking within a million light years. And so she was looking at Cepheid variable stars in the Magellanic Clouds. And Cepheid variables are a special type of star that pulses in brightness. So it gets dimmer and brighter over time, and it does it in a regular period, so that you can count how long between the peaks, and it's the same. It's not the same between stars, like different stars have different periods, but one star will always have that period when we observe it.
Sweet, like it has its season, like it's time to shine?
It has its time to shine, but these periods are really short. They're like 10 days up to 100 days. So it's more like they also have their cycle. They have their menses, and there are times when they're when they're a bit brighter, a bit hotter maybe, and then other times when they're cooled off.
Oh, I love that. Yeah, I always knew I was a star.
Yes.
Yeah. Specifically, what is that term?
Cepheid. A Cepheid variable.
Cepheid variable. Yeah.
Yes.
I can relate.
Yeah, so if you have a regular cycle, you're a Cepheid variable. And if you don't have a very regular cycle, it's okay, because there are variable stars that don't pulse periodically. So we're all stars. So she did that. She was studying their brightnesses by looking at these giant metal plates, which is what the observatory used to take pictures of space on. Like these plates made of like steel or aluminum or something, and they're like a couple feet across, and they end up having little holes poked in them based on where the stars are. And it's wild. She's like physically comparing these plates, or sometimes she might have something that looks like film. But most of the time she's physically comparing these plates that were pictures taken of the same spot of the sky, but on different nights. And she's looking at all of these plates have like 1,000 stars on them. So she's looking at every single star on these plates and then comparing them at different days to see if their brightness has changed.
Oh, wow.
By eye, she's doing this, which is wild to me. I could never.
Right. Yeah. I wonder if it's real or just like an urban legend, but like if one of your senses is different, then it like heightens your other one. So like maybe like if she was deaf and like her eyesight, or she was able to focus better. Like I wonder if there's correlation or causation, but analyzing by eye is wild.
Yes. And we just did an episode on Annie Jump Cannon, who came up with the scheme for classifying stars into different categories. And she also worked at the Harvard College Observatory, definitely worked with Henrietta Swan Leavitt. They were both at one point studying these variable stars. And Annie Jump Cannon was also deaf and also had to look at all of these plates and analyze them by eye. So maybe there is something there, because these two women, these two deaf icons, were also geniuses when it came to studying these stars in this way.
That's so cool. And as far as we know, they were friends, not competitors. We need to stop pitting women against each other.
As far as we know, I have seen nothing to say otherwise.
Oh, yeah. If there was a brutal rivalry, we would have known. It would have been all up in the Harvard Crimson. Yeah. Or like writing shady letters back and forth.
The Lampoon would have picked it up. There would have been a satire about two astronomy women having a feud.
Yeah, that would have been in the... I didn't go to Harvard, but then enough in the hasty pudding theatricals drag show.
This is creating too many flashbacks.
Yeah.
So to bring it back in time to the early 1900s, she is studying these plates for over a decade. She totally commits herself to looking through the plates to find new variable stars. And over her career, she finds 1,777 new variable stars.
Whoa.
Incredible. And she spends so much time thinking about these variable stars and studying their minute changes in brightness. She's calculating their minimum and their maximum brightness, and she's getting really intimately familiar with these types of stars, that she starts to notice a pattern. And in 1908, she noticed that the stars that were brighter had a longer period. She noticed that there is like regularity to the periods, and that there's this extra relationship where if the period is longer, if there's more time between the peak brightness, then that star is on average brighter.
Oh,
always.
Wow. So like longevity and brightness aren't mutually exclusive.
Yeah.
So that's the star I aspire to be, is one that can be super bright and for a long period of time.
Mm-hmm. It's not that the star itself lasts a long time. It's that the pulsing is slow. So a brighter star has a slow pulse, and a dimmer star has a fast pulse, where it might pulse every 5 days, but a brighter star will pulse every 50 days.
Oh, cool. So it's like stable for longer?
It's not about its stability. Actually, all of these pulsing stars are a little unstable in their own way, and I'll explain that in a bit. But it's just that because the star is brighter, it has more energy in it, and that affects how fast it pulses.
Ooh.
Yeah. So actually, at the time, they didn't understand what was going on inside of stars. They didn't know what stars were made of. They didn't understand what physics worked in them. They didn't know about fusion in the cores of stars. They didn't know about how heat gets transferred from the center to the surface. There's so much they didn't know. But Henrietta Swan Leavitt was picking up on really interesting physical processes by noticing that the pulses are regular, because there are other stars where the pulses aren't regular. And so there is something special about the physics of these stars and what's going on inside them. And that's really, really beautiful in my mind. I'm a nerd.
Yeah.
So she notices this pattern, that there's a relationship between the period of the pulsing and the average brightness of the star. And she writes a paper. She has been writing papers up until this point where she talks about all of the new stars she discovers. But she writes this paper. And then at the end, in a kind of throwaway line, she says, "It is worthy of note that the brighter variables have longer periods." So she says the relationship in this throwaway line right after she describes 16 new variables that she's discovered, and she notes that they spend most of their time dim, and that it's only about 1/10 of the time that they spend really bright. So she notices this part of the pattern too, and she just writes it, publishes it, and then takes a couple of years off of work because she gets really sick.
Oy.
Yeah, it's, there are brilliant people who have chronic illnesses, and academia and these spaces are not set up to support them properly. And so we lose out on a lot of brilliance because of it, including Henrietta Swan Leavitt. So she takes a couple of years off, but she comes back. She comes back in 1912, and by now her advisor, Edward Pickering, has noticed her work and has noticed that she's found this pattern. So he puts his name alongside hers on a paper describing the period luminosity relationship. So that's this new law, this mathematical equation that connects the brightness, the luminosity of a star, those are synonyms, the luminosity of a star, and how fast it pulses. And they published this paper, and now it's known as Leavitt's law, but at the time she didn't really get credit.
Oh, boo. But yay.
Boo.
Happy ending, but we'll get there.
Yeah, she gets the recognition now. But back then, Pickering, she was one of his computers. She was one of his women. So I don't know if he explicitly took credit for it, but he was the one who de facto got the credit because she worked under him. And other people started using her law to solve really big questions about the universe. I'll get to that in a second, but she did have to do a little bit more work to make this law real. She kept studying, and there's this, what she was measuring on the plates was what astronomers call the apparent magnitude, or the apparent brightness. It's how bright the star looks to us. But that is different from how bright the star actually is. I'm wondering if you can think of anything you could do to a star that doesn't change the star itself, but does change how bright it looks to an onlooker.
Is it environmental factors? If it's covered up by clouds or smog or whatnot?
Yeah, that's one. On both ends, right? Like we could have smog and clouds in our atmosphere that cover the star, or there could be clouds out in space that get between us and the star and dim some of its light, for sure. You could also move the star.
Whoa.
If a bright star, I mean, not physically, right? But if a bright star is farther away, then it's going to appear dimmer than a dim star that's close to us, right? We've seen this in light here on Earth, like a light bulb. If you have a light bulb in a room and you move farther away, it looks dimmer. Well, it turns out we can actually measure that relationship too. So if we know how far away something is and we know how bright it looks to us, we can calculate how bright it actually is. And we call that its intrinsic brightness. Ooh. So Henrietta had all of their apparent brightnesses, but in order to get their intrinsic brightnesses for all of these variable stars, she needed to know how far away they actually were so we could do that absolute brightness calculation. Does that make sense?
Yeah, for sure.
Okay, great. So she did that. She found a bunch of Cepheid variables that were in the small Magellanic Cloud, and because all of those stars should be relatively close together, they are basically the same distance from Earth as each other, and that distance is the distance to the small Magellanic Cloud. So once people could measure the distance to the small Magellanic Cloud using some other technique, then we were able to calibrate this whole system, and now people could finally use Leavitt's law. They could look at Cepheid variable stars and measure how far away they were just based on the period of their pulsing. And this is now a method that we use to calculate distances up to like 100 million light years.
Oh my God. And it started in 1906?
Yeah, in the early 1900s. She published that first paper with the line in 1908.
That's so cool.
Yeah. So I think now I should tell you a bit about these variable stars and how they work.
Please,
that would be fair. A variable star is any star whose brightness changes, either intrinsically, so the actual brightness of the star is changing, or just from our perspective. And it actually includes a lot of stars. Our own sun is technically a variable star because it changes in brightness by 0.1% every 11 years. It has this cycle. It's very small.
I was about to say, I'm like, that doesn't sound like a lot.
No, it's very small, and we can't even really see a difference with our eyes, but it is technically there. And that is the type of difference that we're also sensitive to in our telescopes for other stars. So there are a lot of variable stars. And some of them are, we call them extrinsic variables, meaning the star's actual brightness doesn't change, but the brightness we measure from them does. And a lot of these are binary stars. If you have two stars that are orbiting each other, sometimes they'll pass in front of each other from our point of view, and we'll see less light from the system. So it just looks like it's variable. But
it's
in actuality,
toxic relationship.
Oh, you're so right. One is eclipsing the other, stealing its light, blocking its shine.
Heard too many of those.
Yeah, you can miss me with that. You're right. The very first recorded variable star that was identified actually was found in 1596 by a German pastor and astronomer named David Fabricius, which is a really fun name.
Yeah, wow.
The star was called Omicron Ceti back then, and it was confirmed to be a variable star in 1638. And that was really important because people hadn't totally accepted geocentrism by then, and showing that there was a star that changed in brightness poked holes in the dominant view that stars are perfect and that space is unchanging and that it will always be exactly how it is right now. We needed that.
Yeah.
Then there are also cataclysmic variables. These are big or small explosions in space. So all of the novae, from regular novae all the way up to supernovae, magnetic flares like a coronal mass ejection, those could be things that make a star appear to be brighter, so it would make it variable.
Ooh, what's a mass ejection? That sounds dramatic.
Oh, thank you for asking. Yes. So stars are bundles of magnetic activity. And we see little magnetic flares all the time, especially on stars like our sun, and especially on M-type stars, which you have previously identified as.
Yes.
They're very magnetically active. But when you have a really big magnetic storm, it can be strong enough at the surface of a star to eject some material off of the surface of the star. So we call that a coronal mass ejection.
Sam, and where does that energy go? Just kind of drifts off, or
Yep.
happens to the best of us?
Yeah. Sometimes the gravity of the star will, suck everything back in. But really, space is not as empty as people think. There are little particles, especially around stars. There's something called the solar wind. So there's this constant stream of charged particles coming off of the sun and hitting the planets in the solar system. So yeah, there's stuff coming off of the sun all the time.
Damn, lots going on.
Space is very active, yes. Including active stars that pulse, kind of like they're breathing. There are some that do this regularly, like the Cepheids, and then there are some that don't have regular periods. I'm going to list a few kinds of them. There are RR Lyrae stars, RV Tauri stars, and Mira-class stars that are all irregular in their periods. There are so many different types of stars. So I just wanted to name them in case you wanted to look things up, listeners, but that's not the focus of this episode. The focus of this episode is the Cepheids, because those are the regular ones. So Cepheids are huge, bright stars. Would you like to guess, perhaps, how they compare to the size of our sun? How much bigger they are?
Bigger? Oh my gosh.
Bigger than our sun.
I'm going to say just a nice clean number. Are they 100 times bigger?
Close. Yeah, they're thousands times bigger than our sun.
Wow.
They can be, right? There's a range, right? Some of them are like 100. Some of them are thousands. They're quite large. And I said bigger. I should have said brighter, because it's not size, but they are thousands of times brighter than the sun, which means they're also very, very hot.
Yeah,
and
wow.
Their periods will range from like 1 to 100 days, so that's how fast they will pulse. And it's not the whole star that pulses, it's just the surface. So the core stays the same size, but then the envelope of the star, as we call it, the kind of like more fluffy, gassy part of the star on the outside, that is what expands and contracts when the star is pulsing. So what's going on inside the star is that it's been trapped inside this cycle of getting bigger and smaller because of some instigating factor, and there are so many things that could have kickstarted this, but it's now trapped in this cycle where when it's compressed, when the star is in its shrunken state, it becomes opaque. So we can't see through it anymore. It gets more condensed. And the photons, which are the particles of light, they get trapped inside, and they're bumping around with each other, and they're causing friction, and they're heating up. And so the temperature increases inside the star. And that means the pressure also increases inside the star because of very fun ideal gas laws that say when temperature increases, then the pressure is also going to increase when you have a constant volume. So the pressure increases and it pushes out on the star. And then the star cools down because it's like, I'm bigger. The photons, they have more room to breathe. They're not bumping up against each other anymore. So the star cools down, pressure decreases, and gravity wins to contract the star. And then it's opaque again. So it gets caught in this slinky.
Yeah, and you're stuck on a subway train and it's all condensed and hot, and you take a step away.
Yeah.
Stars, they're just like us.
They're just like us, you're right. Do you have any questions about that whole process? How does that sound to you?
What's it called? Is that just called just like the natural life cycle of a...
I think we call the whole process just like pulsing.
Sweet.
Yeah, the pulsing of a Cepheid variable. It's named Cepheid because it's named after a particular star that they found that was like this in the Cepheus constellation. But it's one of the smaller ones. Yeah,
that's a small constellation, big impact. That's awesome that it gets a whole kind of star named after it.
Yeah, you're right. Good for you.
Yeah, you go, Seth.
That's how they work. That's how the variable stars work. And in future episodes, I'll probably talk about the non-regular variable stars, because if I'm being totally honest, I don't really know much about like RR Lyrae stars. They've always been a bit of a mystery to me. So I should learn about them, and then I'll make an episode about it. Unfortunately, Henrietta Swan Leavitt died relatively young. She was 53. She died on December 12th, 1921 from stomach cancer.
Oy.
And she was remembered by her family and community and colleagues as a happy, joyful person who was dedicated to her work and family and her church despite her chronic illnesses. Yeah, she was remembered well, but she didn't get much recognition. Even while she was alive, she didn't really get big awards or appointments like Annie Jump Cannon did. So there were women who were contemporaries with her who got more recognition than she did. But her work was used in really big science news. This scientist called Harlow Shapley used Leavitt's law to shift people's mental map of the Milky Way. We used to imagine that we were at the center of the Milky Way, and using Cepheid variables to measure distances, Harlow Shapley realized that we are not at the center of the Milky Way. Edwin Hubble used Cepheids to determine that the universe was expanding.
Wow.
Yeah, pretty big finding. Yeah. Leavitt's law, Cepheid variables were used to calculate the distance to Andromeda, which convinced people that that was a separate galaxy and not just a collection of stars within the Milky Way. So a lot of our understanding of the structure of the universe is owed to Henrietta Swan Leavitt and her law.
Wow, yeah, one of the basic building blocks. And so did Pickering ever get his comeuppance, or no? Like only after the fact we were like, no, let's call Leavitt's law.
That's a good question. I don't know when they started calling it that, but I have not heard much of any comeuppance for Pickering. He employed a lot of women, didn't treat them great, but I think he falls in the middle. He wasn't like awful to them, but he didn't, really try to champion them.
Yeah, the story has a happy ending in that we know her as Leavitt's Law now anyway, thankfully.
I know about her contributions. I actually don't know anything about his contribution aside from hiring all of these amazing women.
That's so funny. That's an accomplishment in itself. Yeah. But yeah, he doesn't have a law.
No, he doesn't. Haha. Suck it, Pickering.
Yeah.
You did want to know if anything was named after her, and yes, we have named a couple things after her, but not things that you can visit, unfortunately. There is an asteroid named after her. It's asteroid 5383, named Leavitt, and there is a Leavitt crater on the moon.
Wow.
Yeah, that's about it.
Has anyone visited it? Did any of the Apollos get to pay their respects?
Oh, no, Apollo didn't visit it. But maybe Artemis can one day.
Yeah, but that's cool to know. And then there's, of course, the law, which anyone can cite.
Yes, I agree. We could all practice using Leavitt's law. It's a really simple law. It's just like an algebra problem, really. Just plug and play. It's beautiful. It's more simple than E equals MC squared.
Yeah, exactly. I have a new favorite now.
That's awesome.
The beauty of the pod. Walk in with one favorite equation, walk out with another.
Yay. So that's all I learned about Henrietta Swan Leavitt and her Cepheid variables. Do you have any lingering questions?
Oh, I think that covers it. I want to go to the moon.
Perfect. Well, we're in the Berkshires now, but maybe we could meet up next time at a launch site. We can play Don't Stop Me Now and swarm the rocket, go up on the moon.
Exactly. Having a ball.
Love it. Well, we're about to go build a bonfire here in these beautiful Berkshire woods. But before we do that, Orli, can you brag about yourself for a little bit and tell the listeners where to find you and your work online?
Absolutely. Thank you. One day there will be Matlow's Law, maybe. But in the meantime, I'm a stand-up comedian and writer. I'm on all social medias as @HireMeI'mFunny. Please do if you're listening. And my website is orlimatlow.com. Keeping it simple.
Good.
Yeah, thank you so much.
Thank you. We are so happy to have you here at Pale Blue Podiversity. I'm really excited to see what you do in your academic career, and you get 5 gold stars. You did so well in this first class.
Thank you so much. I'm excited to have an opportunity. I didn't make the improv team when I was in college.
We have a great improv team, and I know that they're looking for new players.
And maybe some mezzo-sopranos in the a cappella group.
I think you'll be able to find your people here, Orli.
Yeah, I hope to see you guys all on social media, if not on the moon when we get there.
Perfect. We're going to go make some s'mores. Whether you're on the moon or looking up at it, listeners, remember, you're still space. Bye. Pale Blue Pod is hosted by me, Dr. Moiya McTier, a.k.a. the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.